In this tutorial for Explorer, we're going to run t-test, Mann-Whitney tests, analysis of variance, and Kruskal-Wallis tests. So let's get started. First, drop a data import icon onto the workflow, and then we're going to go to independence, and then drop two feature selection variable icons on this. And then for grouped analysis, we can use this again for the t-test and also ANOVA. So we'll use the two sample tests up here in the top workflow, and then the k-sample test for ANOVA and Kruskal-Wallis on the bottom. So let's connect the data import icon to the feature selection icons, which are feature selection icons are in yellow. And then let's connect this to the grouped analysis, and same thing here. Connect this to the grouped analysis. Let's import the data. Let's use the retinol data set. This is in your NXG Logic Explorer data file folder in your My Documents folder in Windows. Double click on retinol. The data are imported. There's 14 features, 3 of which are categorical. Gender, we'll use gender for t-test, and either smoking status or vitamin use for the ANOVA, which both have 3 levels. There's 314 objects and 14 variables. Let's go back to workflow. Let's select the variables that we're going to use for a t-test. Gender has 2 levels. Let's select that as the class feature or the grouping feature. And then for the t-test, let's run age, gender, calories, catalytic calories, fiber, and cholesterol. Click on OK, and then for analysis of variance in Kruskal-Wallis, let's select smoking status as the grouping variable, and then age, catalytic calories, fat, fiber, and cholesterol. So we are ready for the runs, and we can just click the run icon here, and both of them will run. So they've already run. So here are your 2 groups for gender, and then your continuously scaled variables, the variable name, the means, standard deviation for each group, the test statistic with the degrees of freedom, and Bartlett's homoscedasticity or heteroscedasticity is run with p-values. So blue p-values are not significant. Red are less than 0.05. Now, when at any time Bartlett's test is significant, it means that the variances are unequal, significantly different between the 2 groups. So we see that for catalytic index they are different, and that's borne out by the 6.2 versus 4.18, but here they overlap a little bit, so not too much different. This was different because the standard deviation you can see is a lot different. If you square these, it's going to be much larger values. So significant Bartlett's test for these, and these were not. So the point is that when Bartlett's test is significant, the degrees of freedom will be altered for the t-test, and when it's not, the degrees of freedom is the same for all of these. Remember, it's n1 plus n2 minus 1 for the degrees of freedom when it's unaltered. And we can see that now for the p-values here, for the t-test, and also this is the Mann-Whitney z statistic here, and the p-value for Mann-Whitney is shown here. So the 2 tail probabilities. Age is significantly different between the 2 groups, as shown by the t-test p-value. Calories was significantly different between the 2 groups. The fat value was also significantly different, but the catalytic index and the fiber was not. So here you have the results of a t-test with the variable shown that was used for grouping here, sex, and then the null hypothesis that both means are equal. Now let's go to the results for, if you recall, we ran we specified that a 3-level factor was used, or a 3-level nominally scaled variable was used for the test. So that will result in ANOVA. And here's the output for smoking status. Here's your 3 groups. And then the F statistic with numerator degrees of freedom and denominator degrees of freedom. And then the Kruskal-Wallis test is always run. And then Bartlett's test is also run for the 3 groups. And then if it's significant, you can see the denominator degrees of freedom are changed, but the numerator are not. So for these 4 variables, age, fat, fiber, and cholesterol, They did not have significantly different variances for the three groups. So therefore, Bartlett's test was not significant, and then the denominator degrees of freedom was not altered for these, but it was for the Catalet index and the calories variable, because there Bartlett's, you can see the denominator degrees of freedom are different than the 311 here, because Bartlett's test was significant. So you have, again, for your three groups, the means, the standard deviations, and then your F statistic, numerator and denominator degrees of freedom with the p-values, and then the Kruskal-Wallis non-parametric K sample group test, and then the Kruskal-Wallis p-values, and then the Bartlett test, which is chi-square distributed, and its associated p-values. So going through here, age had significantly different means across the three groups. Fat did, fiber did, cholesterol did, but Catalet index and calories was not. So there you have a workflow set up to run a t-test and the associated non-parametric variant, i.e. the Mann-Whitney test, and then analysis of variance and its associated non-parametric variant, i.e. the Kruskal-Wallis. And we see that in both cases for two sample tests or K-sample tests, you use the same feature selection icon for grouped analysis, and then for both the t-test, two sample tests, you use the grouped analysis icon here. It's just a matter of what you specify for the grouping variable here. So if the grouping variable you specify in this feature selection for grouped analysis has 3 or more levels in it, you'll have analysis of variance and Kruskal-Wallis run. But if you have 2 levels of a factor, if you select gender, Explorer will determine that there's just 2 levels, and it will run t-tests and Mann-Whitney here, as we've seen.